My name is Vassili Bykov, and I worked with Smalltalk since 1993. And well, for the past 5 years, actually, I have not worked with Smalltalk. I worked on Newspeak. But before then, I was the technical lead of tools for VisualWorks for 7 years, and before that, I worked for the object people. And people with gray hair in the audience, they probably remember what it was. And so the talk today is about Newspeak, and it's about good thinkful programming. So who here has read 1984 in English? Okay. So to explain, good think is an official term from Newspeak, from the original Newspeak from the 1984 universe. And it's a term that describes the officially approved line of thought, which is, of course, the only possible line of thought. And Newspeak was designed as a language derived from English it sort of ties into Ian's talk yesterday, to make it impossible to formulate ungood thinkful thoughts, and to encourage formulating good thinkful thoughts. And well, Newspeak that we have, well, it is called Newspeak because precisely because it is derived from Smalltalk, but with the purpose of making some things easier to express. And just like the original Newspeak, it was defined by gradual elimination of features from Smalltalk. So it started in Squeak, and then Newspeak 0 was essentially Smalltalk, but without the literal array syntax, and then other things were eliminated. So in plain English, this talk is about how to use Newspeak. And the conference program says that I would talk about Hopscotch, but, well, we'll definitely see Hopscotch, but I decided that this is actually something that is more useful in this audience. Because I find that Smalltalkers are very good picking up Newspeak. So we had contributors who used Smalltalk before. They come up to speed very quickly, but there are some things that are different. And this is something that I don't think we've done before, like just a talk that is targeted at Smalltalkers and explains what is different, like where the intuition can break. And I think this is more useful than just talking about the details of Hopscotch. There's a paper on Hopscotch that you can read, and there hasn't been any major changes since that paper, since 2008. So who here knows what Newspeak is? Okay, about half the people. And has anyone written at least one class in Newspeak? Oh, excellent. 2 people? Okay, well, very well. So this is exactly what this talk is for. So, well, to go over a few points that, well, people were asking me offline. So Newspeak is a language that is influenced by Smalltalk mostly and Beta. And it was bootstrapped in Squeak, as I mentioned, by gradual elimination of features. And it still runs on top of Squeak. It's hosted in Squeak, and well, we'll see what it looks like. And the initial work was done as a project at Cadence since late 2006 and until 2008. People ask how it was possible and how much Cadence is invested in Smalltalk and in Newspeak. Well, the answer is this was a new business incubation project, so there was an application that Cadence was interested in. And it's just the setup was such that we were able to work on Newspeak as the platform for that application. Well, what the application does, I'm not supposed to tell, but you are not losing. Believe me that you are not losing anything by not knowing. And then in 2008, the project was canceled. Not because of anything that was wrong with the project, but because of the financial crisis, or rather the combination of the financial crisis and some creative accounting. And in 2009, Newspeak was open sourced, and well, you are welcome to contribute. There have been a number of contributors, well, as I said, some of them Smalltalkers, some of them non-Smalltalkers, and we found that Smalltalkers, it is raining quite hard. Can you still hear me? Well, then there was a brief period for about a year, well, less than a year at SAP when Gilad and I were able to use Newspeak in a prototype of a project. And well, we have done some interesting work that included compiling Newspeak to JavaScript and running inside the inside V8. And well, I'll mention something about this. And the breaking news, the recent news is as of last week, Elliot and I started at Cadence again in a project that is well, somewhat similar to the original one. And so we're going to work on Newspeak and be paid for it, which is a very good news.
But there is a financial crisis again.
Well, we'll cross that bridge when we get there. So now, well, I would like to kick things off by having a little exam. So this is a university, and this is what they do here. So yeah, and if you don't pass, then you don't get to eat dinner today. So be awake. Well, everybody knows that we have nested classes in Newspeak. So let's say we have two nested classes. There's B nested inside of A, and we write this expression. It's in Newspeak, it means exactly this, well, almost the same thing as it means in Smalltalk. So we start with A, we send the message B to it, and then we send the message new to the result. So raise your hands if you think that this is an incorrect expression and it cannot work. Okay, and can you explain why? Okay. So one person took a random guess, thinking that there's a 50% chance. That's good. So yes, the expression is indeed incorrect, and the reason it is incorrect. Okay.
What do you say? Scope problem. I have a feeling that B is not within the scope that you think.
Yeah. That's so the. Well, it has something to do with the scope problem. So let's see how this works. So we have A and we have B enclosed in it. So what that means is that any code you have in the class B, it is lexically enclosed in class A, and it has access to everything that class A has. So let's say class A has some state. So B obviously has access to that state. It can access those slots and whatnot. So what that means is, can we have an instance of B without having an instance of A? Well, obviously not, because this is where the instance of A is where that state would live. So that means that class nesting, it actually implies object nesting. Yes?
The class B is what has access to the variables of A, or the instance B has access to the variables?
The instance, yes, we'll cover that. So what exactly class means when we talk about classes and when we evaluate these expressions. Yes, so it turns out that we cannot have an instance of B without having instances of A. So when classes are nested, instances are also nested. And so the correct way to work with this nesting structure is we start with A, we create an instance of A, and then B is something that we can retrieve from that instance. And that B, in Smalltalk, when you evaluate a class name and you get an object, that object actually has a number of responsibilities that are distinct. So one of them is the factory. So this is what you use to create instances of that class. The other one is a reflection facility. You can find out things about that class, so they do not have to be the same. In Newspeak, in contrast, when you evaluate the name of a class, what you get is the factory. So in this case, when we send B to the instance of A, what we get is a factory that will produce instances of B that are nested inside the instance of A that gave us that factory. So this is, well, in a way, it's sort of like a closure. So we start with this instance of A, we ask it for the factory of B, and that gives us a specialized factory of B that will produce Bs that are nested inside of the A that we started with. So this is how this object nesting structure is essentially enforced by the language. And well, the follow-up question is, so let's say we have these two expressions. So we create a new instance of A, we send a message B to it, we save the result. And we do the same thing again, we save the result again. Are they identical? No, of course not. Yes, exactly because of what we just discussed. And well, another question, can we ask A for, say, the list of its instance variables? So yeah, that's again, in Newspeak we can, because A is a factory, and well, it can tell you the name of the class just for the convenience, but a lot of the behavior that you would expect from a class meta object in Smalltalk, you will not find in the things that you get in Newspeak when you work with classes. Instead, you would use mirrors. So you would create a mirror on that class, and that mirror can will let you find things out about this class if you have permission to do so. And well, and the fourth question is, can we actually say A that we started with? Well, the answer is it depends. So it depends on whether that A is actually visible where in the place where we have that expression. So another difference, an important difference between Newspeak and Smalltalk is that in Newspeak there is no global scope. So there are no globals, and there is no system dictionary, and so you cannot just write ordered collection somewhere and expect to get a reference to the ordered collection, or the ordered collection factory. This would be the case in Smalltalk, just because it's defined somewhere. So you have to actually arrange for that reference, well, to get that reference somehow first. Well, I went through these examples just to show that the points where the Smalltalk intuition breaks down when you start looking at Newspeak. And so these are the important things that you have to start with if you look at Newspeak. So objects nest, and we covered that, and well, you saw how that nesting is enforced. And well, classes, they seem, well, it seems like we work with classes just like we do in Smalltalk, but what the objects that we talk to, they are slightly smaller in the set of the responsibilities they handle. Well, I'm sad to say this in this conference, but there is no Smalltalk, and there is no Newspeak, there is no system dictionary. So this is, like, if you think about this, this paints a picture of a pretty different world from Smalltalk. So how can we work with libraries? How can we create an instance of an ordered collection if we don't see ordered collection to begin with? Then how do we structure our own applications? Well, we have these nested classes. We want, and we'll talk that the reason for, one of the reasons for having nested classes is to provide modularity and to have a packaging story. So what does it exactly mean? What does it exactly mean? How do we do that? And also at the UI level, the IDE level, as an IDE designer, how do you work with nested classes? Like if we look at the wireframe of the classical Smalltalk browser, well, we have 4 panes for lists and 1 pane for the code. And the reason it works so nicely in Smalltalk is because we always have this 4-layer hierarchy of things that we browse through. But in Newspeak, with nested classes, the hierarchy can be arbitrarily deep. So following the same pattern, we would need an arbitrarily wide browser and probably an arbitrarily wide screen. And well, Tudor, I saw that nice sliding thing, and it's very slick and it's very well implemented. And it is. I'm kind of half kidding with this picture. It's appropriate in some things, but I wanted to try something different, like an idea that is organized differently. Well, for some other reasons too. Well, one of them avoiding modality, which is not easy to do with this form-based interface. And so, well, this is what we're going to look at today. So it's mostly like a practical session of, well, where do you start when you start Newspeak. How do you create your application? So what does it mean to create your application? We don't really, perhaps we should have some sort of a button that guides you through it, like creates the boilerplate that defines an application with nested classes, but we don't have it yet. What modularity means and how it works, like all of this is just a certain discipline of using nested classes. And of course we'll use Hopscotch. So it's not a talk about Hopscotch, but well, you'll see some glimpses of it. And as a bonus, and I hope we'll have time for that, we'll look at the testing framework for Newspeak, which is different from, it's not XUnit, so it's not based on the design, the common design for, that was based on Smalltalk unit. It's completely different, and again, it's a good example of use of nested classes to structure tests differently. And yeah, if you remember your 1984, then you will catch the pun of the name Minitest. So, well, before we start, well, a reminder to those who looked at Newspeak and some necessary information for those who haven't yet. This is what a class declaration looks like in Newspeak. So in Newspeak, unlike Smalltalk, there is source format. So there is syntax for a class. So a class can be, I think yesterday someone mentioned Carl, and the ability to have a script in Smalltalk, which well, defines a program there. So well, in Newspeak, well, there is a syntax for a class. So you don't need a browser to necessarily define a class. And the syntax, well, you specify the name of the class. So in this case, we want to define a class called coloredPoint, which is a subclass of point, and it adds a color. So we say the name of the class, coloredPoint, and then we give a message pattern. And this message pattern is we call it the primary factory. So this is the message that you will send to the factory of this class to create instances. So when you get a reference to coloredPoint, you will say x colon, y colon, color colon, and that will give you instances of coloredPoint. And well, the line below, well, usually we write it on one line, but it formats better this way, is the superclass. So the superclass of coloredPoint is point, and here we say, well, by writing this definition, we also define the factory, what the factory does. So here we say that when we create an instance of coloredPoint with these parameters, we want to pass x and y to the primary factory defined by the point class. So, well, presumably point has a primary factory that's named x colon, y colon. And then what follows is the class header, which defines a single slot named color, and we initialize it to the RGB parameter. So what does it mean to define a slot? Well, it is sort of like an instance variable in Smalltalk, but in Newspeak you don't access instance variables. When you write what looks like a reference to an instance variable, it's actually just like in self. It's an implicit, it's a message sent with an implicit receiver. So when you define a slot like color here, you automatically, or the system automatically defines for you a getter for this slot. And in this case, it will be just a getter, because we use, when we use equals, it defines a read-only slot. So the only place it can be initialized is here in the initializer for the class, and then once it's set in the instance, you cannot change it, so there's no setter, but well, there is a different syntax that can define mutable slots. So for mutable slots, you get both accessors. And then this header is followed by the body, which contains nested classes and methods of this class. So, well, I had to cover this because we will look at many code examples, and they would not make sense without this. Okay, and now is the time to look at the actual system. Can you still hear me? And people in the back? Not so much? How about now? Okay. All right, so here I start a Newspeak image, and what I get is the Hopscotch window. So this is the browser that gives you access to the system. And it's structured sort of like the web browser. There's the back button, the forward button, and like history and the home page, and well, they work the way you would expect them to work. And the things that you see here on the home page are, well, some of them are access to the system source. So this is how you get to the system source to browse it and to modify it. And some of them are convenience links to, for example, classes that you recently visited. So for example, if I click on this link, I jump to the home presenter class, and this is what the class looks like. So you have a header up on top, and nested classes, of which there are none in this class, and methods. And well, before we start talking about the with the example, I want to show off. So to show off, well, here we have the system menu with an item that's called Show Console Window. So we have a very advanced console window. It has an entire Smalltalk system with a squeak browser and other useful things. And so I'll make the window a little smaller so that you can see both of them. And now on the File menu here, I'll go to Preferences and say Go Morphic. So watch the Hopscotch window that you have there. So the window disappears from the screen, and it's now inside the squeak window. So this is to answer the question some people ask, so do you write your, like, are your interfaces implemented in Morphic? So the answer is no. They are implemented in Brazil, which is the UI framework, so named after the movie, the UI framework of Newspeak. But the UIs that you define, they are eventually expressed as artifacts, either in Morphic or, well, currently the only native support that we have is Windows. So they can be Windows, or they can be squeak windows inside the squeak window. And well, here you see I can open like all the usual things that you expect to see on a morph. So these are morphs. This window is now built on morphs. And this remapping, this mapping of Brazil UIs to artifacts of some Windows system, it's dynamic. You can do it on live Windows, just like we've done it now. So now in this browser that is now lives inside the squeak window, I can go, for example, to a different page, and now if I switch the system to native mode, the window jumps out, and now again it's a native Windows window, and so this button, for example, it's a native Windows button. It's no longer a morph or anything. So we don't paint things, well, not many things inside the window now. Well, now this window is native. So this is sort of to give background on how we build our UIs. And well, now back to the example. So how do you work with the system when you get this window? So, well, presumably you want to write an application. So writing an application means that, well, you go to the system source, and in the system source you see the list of packages and categories inside the packages. And, well, you can add a category by clicking this Add button, well, either in the Unpackaged section or in one of the packages. And, well, here you type a nice and descriptive name for your category. You accept it, and now you have the category in the list. And if you click that link, it leads you to the view of the category, which is currently empty. And this button, the plus button, this is what you use to create classes. So for this demo, well, as I said, to define an application in a Newspeak application, you need to create a certain structure of classes. And so to not waste time on that, I actually already have that structure predefined here in the demo category. And well, first I'll just do the demo. I'll use the structure, but then we'll go through the slides and I explain what the structure is and why it is the way it is. So it is, the application is a top-level class, not nested in anything, called demo app. And so it has some initialization code. It has a method main, which may be intuitive to some people. And we'll talk about what they do and why they are the way they are. And inside we have a nested class called demo module. And demo module is a module inside of our application that actually defines this example UI that we're going to build. And the example UI, it's a Hopscotch UI. So, well, again, I'm not talking about Hopscotch, so I'm not going to explain what subjects and presenters are. You can find a paper online on that. So we already have, but yeah, subjects and presenters are something that you define to create Hopscotch UIs. So, well, here we already have a subject created, so we'll create a presenter class. So to create a class, so we'll create a class inside the demo module. So demo module is, well, as we saw, it's a class nested inside demo app. So this line at the top, it reminds us about that. And to create a class nested in demo module, we click the plus button inside at the top of the classes section. And this gives us a template for class definition. And well, to save time, I'll cheat, and instead of typing, I'll just copy the class definition we want here. So, well, now we are ready to create a class called demo presenter, and well, it has the primary factory required by the framework. But something I want to show right now is what I mean by saying that this browser is not modal. So at this point in a classical Smalltalk browser, you wouldn't be able to switch your view. When you start modifying a class definition or type in a new class definition, the view of the system is locked. If you want to look at something else, it will tell you, well, do you want to abort your edits right now? Well, here, I'm still free to do whatever I like. Well, I can look at something else. I can expand and collapse things in this view. I can dive into the demo subject class, and then I can go back and find things the way they still were. So I still have my definition not accepted. Or I can look, let's say I want to look at the presenter class that we are about to use here and verify that I'm actually using the correct factory method, message name. So I'll type presenter here in the search box at the top. In double quotes, because otherwise it will find everything that contains presenter, and that's quite a lot. And so we will find two matches. One of them is actually in, I think it's in Morphic. Let's look. Yeah, it is in Morphic. So this is not what we want, and it has different icons. This blue icon, it means it's a Smalltalk class. So we can browse Smalltalk classes. We can work with Smalltalk code from Hopscotch. And this one, it's kind of green, and you probably can't see it, but there is a tiny little digit 3 in it, so it means it's a Newspeak 3 class. Well, Newspeak 3, it's our internal way of keeping track of generations of the system. So the current generation is called Newspeak 3. So that's this gradual removal of features and well, making the good thinkfulness stricter. So yeah, we can click on this class and we can see that yes, indeed, the primary factory is called onSubject. So our definition back there is correct. So we can go to history and go to the demo module and finish creating our class. So we finally click accept, and we get our demo presenter. And if we click on it, we go inside and we can add a method. So the method, a presenter needs at the minimum, needs a method called definition. And we won't be very ambitious, so we'll just say that the UI that we create, it will contain a label that's going to say, hello, brave new world. And so we save this method, so now it's live in the system. And we can go back to the application. So we can just click this link up on top, which shows the nesting. So it will go into the top level class that contains everything. And if you see, there is a tiny little action link here that says run. So this is an action that will actually run this application. You see it here, but you don't see it in other classes, such as this, for example, because the system recognizes that this is an application, because it has a certain signature in the primary factory, and it has this main args method, so it has a certain shape that an application needs to have. And so, oh wow. This was actually a preview of what's about to happen. So well, whenever you you run a new application, of course it blows up, it breaks. So yeah, so when we run it, we get an error, because this is what typically happens. And well, we get an error because I wanted to show the debugger. So the debugger in Hopscotch, it's implemented in Hopscotch, and it's the main feature of it is the call stack. So we see the stack, and well, we see that the problem was that an object here, a class factory, it does not understand a message called bogus message. And if we open this stack frame, we can look at the details. So in any stack frame you can open, you can look at the source of the method, and you can view the values of the variables in this method and visible from this method. And you can expand them to look at details, and so like this whole navigation thing works. So in this case, we're interested in the second frame where we send the wrong message to create an instance of demo subject. So we're going to replace it with the correct message, which is new, and we save it, and so we throw off everything on top of the stack above this method, and now we're ready to continue. And we click continue, and well, now we succeed. And so this is a Hopscotch UI with the label that we wanted to create in our definition. So these are sort of the general steps of how it works. But now we have to go back and see what our application looked like and why it was, and also understand why it was structured that way. So as an example, we'll look at the definition of the class called demo subject. So when we define it, well, here's the definition. We define it as a subclass of something called subject. So let's go back to the slides. So we define demo subject as a subclass of subject, and as we talked before, we cannot simply say this and expect it to work because we have subject defined somewhere else. We have to make arrangements for this name to actually mean something in this scope. So the arrangements step in one level up, and this is an example that you will see in many papers that exist on Newspeak, and it's not exactly how the system works now, but I start with it because it's simpler. So you would see this example. So it will say that the code that we write to create our class, so the class that we create, it's nested inside a module there somewhere. And the module is a top-level class that is created using a message, something like using platform. And the parameter of the message is an object that is provided by the system, which is an access path for getting to libraries that exist in the system. And so down below we can say, so if you remember this syntax, well, I put the vertical bars in a different place, but this is a slot definition. So we create a read-only slot named subject, and we retrieve Hopscotch from the platform, which presumably is the Hopscotch module, and we create, we retrieve subject from that module, which we expect is a class factory, and we save it in the slot here. So this works sort of like an import statement, except it's not an import statement, it's just a slot. But it And so this is close to the way things work for real, except we have some additional details and an additional level in the structure of things to allow for packaging. So for real, in the code that actually worked just now, we would define this containing class demo module to accept the Hopscotch module as its parameter. So it would come, we would give it, we would create it somehow, and then pass it to the module, and then we would retrieve the subject from that instance. So, well, as a matter of fact, in this example, well, we don't even need to save Hopscotch to save a reference to the Hopscotch module. It would be enough to just use the parameter to retrieve subject from it at the line down below. And one level up is the application definition, that demo app, the top level class. And this is where the actual work happens. So it has the primary factory, which is well, expected by the system to be named package using. It accepts a platform, and it retrieves Hopscotch from the platform and saves it as a slot. And that Hopscotch is a class factory. So, well, modules, let me step back or step away a little and kind of explain the terminology here. So we started talking about modules. Modules in Newspeak, they are classes that contain well, your code. And so being classes, they follow all the usual rules, meaning that we define them, when we write a definition of that class, we define it in the system. When we start using it, we get a reference to the factory of that class, and then we can use that factory to create instances. So that means that when we wrote our demo module there, so what we have here is the demo module definition. If we ask for demo module somewhere in the code, like you see in the main method there, we ask for the demo module, so what we get back is a factory of that module, and to create the actual module, we have to ask the factory to create it as an instance. Right. So, well, modules they are just classes with that we instantiate. So the same rules apply to Hopscotch. So like up there, we retrieve a reference to what we expect to be a class factory for the Hopscotch module, the factory for the Hopscotch module, and down below in the main method, we instantiate the Hopscotch module. So, and this is an instance that we can pass to our module. Is this confusing? Okay, well, we'll revisit.
If there is no globals, why you are using capital letters?
By convention. So capital letters we typically use for slots that reference class factories. I shouldn't say class factories, that reference factories or classes. And lowercase letters, they slots with lowercase that are not capitalized, they contain instances. This is why the slot Hopscotch up there, it's capitalized, because like as an indication, it's just a convention. It doesn't have to be that way, but it contains a factory that will create the Hopscotch module. And down in the main method, the Hopscotch variable is it's lowercase because it is an instance of Hopscotch module. Well, we'll revisit this example once more. So, well, hopefully, if you don't follow yet, maybe you will. Well, an interesting point here is why do we have things split into two parts? So here we have this highlighted code. So up on top, we have the class initializer that retrieves a reference to the factory of Hopscotch. And then in the main method, we use that reference. So in principle, we could have just done everything either in the main method, because the main method, well, it gets the same platform argument as we use up there, or we could have done that everything in the initializer, all in one place. And the reason we split it like this is because we want to support packaging. So what is packaging and how does it work? So packaging is when we develop our code in our environment, and then we want to take our application, take everything that it requires, and save it as in some form. So it can be serialized format, a Newspeak object format, or for example, I mentioned compiling to JavaScript. It can be a JavaScript file. So I want to take my demo app, and I want to say, take the closure of everything that it requires and write me a JavaScript file that will contain translation of everything that it requires, and that will run when I run that file. So that would be packaging. So how it works is, or what we need to do for that, we need to find out the dependencies of our applications. So our demo app requires Hopscotch to work. And Hopscotch, it requires presumably some other things. For definitely it requires collections. I mean, there is a collection or two in there. And we need to be able to find out these references. So if we go back and look at this definition, the part on top, the one that is in the initializer, is essentially a definition of the dependencies of this application. So we just say that we want Hopscotch from the platform. And this is the reason we split it like that. So what we can do now to package this application is we can take the factory for demo app. We can, as the platform parameter, we can create an object that users does not understand to record the messages it receives. And we invoke package using on that factory. So that creates us an instance that we're not going to use for anything. So it will run that code at the top. It will create an instance that we're not going to use for anything, but the object that we passed as the platform parameter will record what packages this initialization code tried to retrieve from the system, what libraries it tried to retrieve from the platform. And this is how we will know that our demo app requires Hopscotch. And then we can repeat the same with Hopscotch and find out that it actually requires collections. And so this is how we discover what we need to package, and then we can make a nice, neat package of everything that's needed and nothing else. And then when we execute that package, the reverse process is we create everything that's in the package. So we will create some artifact. Let's say we are running in JavaScript, so we'll create whatever artifacts we need to create in JavaScript to have a translation of the factory for the demo app class and for Hopscotch and for collections. We'll create an object that will act as a platform, such that when we send it the message Hopscotch, it will return Hopscotch. We send it message collections, it will return collections, so it will function as a platform. And then we instantiate demo app by using the factory, and we invoke the main method. So when we execute this code, we actually we create an instance and we send it the message main arguments to actually kick off the execution. So this is how it works. So this is the reason why things are split into two parts. So at the packaging stage, we only use the definition of dependencies up there, and at the execution time, we actually execute everything. So any questions at this point? It's because everything's clear or everything's unclear? How to have more dependencies?
How do you add more dependencies on the code?
So more dependencies, for example, in this code, you mean how can demo app depend on more things? Well, if you need collections in there, you define another slot in the class up on top. You say collections equals platform collections, and well, and there is your dependency on collections.
Another question: how do you know what things you can add to platform?
Well, that's the tools issue, basically. That's what your tools have to allow you to do. So, well, platform in the IDE in your tool, platform is something that is magically provided by the system. So this is the key to living in this world where you don't have the global scope. You don't have global, so you cannot just go out and grab something, but you expect that something will use magic to create this object that we call platform, and that object it will allow you to get at something that you want to use. And so that means that well, in your system you can look how that magic is implemented. There is an implementation of that platform somewhere. So in Newspeak we have a class called platform, and it actually implements the logic that that defines what you see in the platform.
And is it the idea to have different platforms for different environments when you run your application, like the browser?
Yes. So for example, like in the JavaScript example, if you define this application in the current system running in Squeak, and you run it in Squeak, the platform is what you get, is something that gives you access to things in the current image. But if you deploy it, if you generate a package and then you run it at the other end, the platform will be this object we have on the right that gives you access to the translations of these dependencies. So yeah, platform is a reference to the system, but yeah, that's all you know about it. And it can be the same system you developed on, or it can be something different. Yes?
So presumably you share behavior between all instances of a particular type?
Yes.
So there is something still a little bit like a class, or maybe like a map there associated with a factory for each of the instances?
Right, associated with it, but it's not the same object. Yes, the question was that, well, presumably all instances share the same behavior, and so there is something that that allows that sharing. So something like, well, like in the Smalltalk system, you have your classes, and class has a method dictionary, and this is why all instances share the same behavior. And so even though here, when you work with classes, when you name a class, you get back a factory, but of course there is also something that supports the sharing of behavior between these instances.
So then, are there any complications then due to object types returned from primitives that are not explicitly dependencies by having a slot initialized in a class for which they are used, or in a factory for which they are used? So if you invoke a primitive that returns, say, a point, and you have not anywhere in your application initialized a slot saying, I want to import a factory for points. So there's no explicit notation, denotation of the dependency on a point, yet a primitive in the system may return a point.
Well, okay, if I understand the question, it's, do we have a microphone in the audience? We used to have a wireless mic.
No, I can ask at the end again in the Q&A.
All right.
Or now.
Well, let's go now. Yeah.
Okay. So it may be possible for a primitive to return a type of object that you have not listed explicitly by initializing a slot in one of your classes.
Right.
Now, are there any complications then when you do this sort of closure generation to include the behavior required by those types returned from primitives?
Well, I don't see complications because, well, this is just like in Smalltalk, you don't really expect that, or you should not expect that object to be an instance of a particular class. You should expect it to have a certain behavior. So let's say if it's a point returned by the system, your expectations will be that it will understand X and Y. And the exact structure of that instance is something that well, you really cannot see, since you cannot ask for a class of it and get a mirror. You will have to go to the mirror system and well, get something that describes the structure of that thing. And well, in this way, we can play tricks with the mirror system too. So you are either just cannot see inside that thing, or perhaps you see some simulated view of whatever is that. Okay. All right. So well, are we on time? Okay. Well, we have a few minutes, so I'll say a few words about the testing framework. So Minitest, the testing framework. So why don't we use XUnit? So as a matter of fact, there was a testing framework based on SUnit. It was called NSUnit, and it had a very similar structure. And this is why it was about a year ago I defined Minitest. That's when we started working on a JavaScript compiler, and we wanted to have good tests. And it turned out that it was very difficult to use as NSUnit. And it was very difficult because, as you just saw, there is a very particular structure that we expect our applications to have, and how they get to, how you run them. And SUnit and SUnit, pretty much all those unit test frameworks, especially in an interactive environment where you have the test runner, they make assumptions that are incompatible with ours. So you cannot just, let's say you have, you define tests for well, whatever class you have, like foo tests, which is a, so you define a subclass of test case from SUnit, you write your tests, well now you want to run those tests. Well the test runner will expects that the way you run them is you select your class and then it does whatever things it does to run those tests. But in our world, you cannot just create an instance of a class nested inside a module. You have to configure that module. You have to create an instance of that module properly configured, pass all the correct dependencies to it, and only then you can get a class or a factory that will give you the test cases that you can actually run. And so this whole model is not really, these two models are not really compatible. And another reason I always found SUnit to be somewhat counterintuitive, and I had that feeling that it mixes concepts. Like for example, we define our tests as subclasses of test case. So you create a subclass of test case, and then you write a bunch of methods that say test parser, test code generator. Well, they would be more specific, but well, you get the point. Yeah, test addition, test removal, like the canonical example from Ken's paper on that. And so, what is test case? Like when we talk about test cases in our everyday speech, we would typically call one of those methods a test case. So we have a case that tests that additions work for our ordered collections. But the test case class is actually, by that logic, is a test suite because we have a whole number of tests in it. However, we have a class called test suite in SUnit, and I could never quite figure out like what's its purpose and what it does there, except I never had to use it. And then there is the setup business that so you initialize your instances of test case in a method that's called setup instead of initialize. And in clones of SUnit, such as JUnit in Java, where you could argue that this is just a convention, but well, in Java, where they have constructors for initializing instances, why are not those constructors used to initialize instances of test case? Why do we still have to write the setup method? And well, all of those things that kind of I couldn't figure out how to work with them. And I understand what test resources are for, but well, every time I had to use them, I had to actually remind myself again how I work with them. So, well, let's think how we can redesign it. So, like taking Ken's example from the SUnit paper. So let's say we have a class, well, in the original it was ordered collection, we call ordered collection lists in Newspeak. And it has methods add and remove, and we want to test those methods. So what the paper talks about is that what we define is, we need to define something called a text fixture. And actually test case should have been named test fixture, because that's what they are. So a test fixture is something that defines how a set of test cases being individual methods that test things, are executed. So they typically expect a number of objects configured in a certain way. So in this example, well, it's a trivial example, we would have a list instance that we work with to test. So a text fixture would contain some local storage, instance variables for those instances, the code to initialize those instances, and of course the tests. And so, well, I found that fixture is a term that is not, also not quite intuitive, but if we look at this, so what we're trying to do with these fixtures is we're trying to define a context in which we run tests. So if we want to test, say, addition and removal of elements in a collection, well, we expect our context to have a list there. Right? So a test context is actually a term that kind of captures what the role of those fixtures. So in Minitest, you define tests as subclasses of something called test context. And so, well, here's a definition that would work. And so we have a slot that holds onto an instance of list. We have the actual tests. And we'll also have a marker. And this is the code that would work in the system right now. Ideally, this marker, so this marker is what tells the testing framework that this is a test context class. This is a place where it needs to look for test cases, for these methods that begin with test. In a completed system, this marker would be an metadata of a class, well, annotation, pragma, whatever you call it. We don't have those yet, and so this is a quick and dirty solution that you will see in the system if you look at it now, is there is just this method with all uppercase test context that tells the system that the testing framework that this is a test context. So test contexts, they are recognized by the presence of this method and not by inheritance from test context class. The test context class, it just provides the behavior you need to have in tests such as the assert and deny methods. So it's there just for the behavior, but they don't need to inherit from that method, and that adds the separation between the role of not using inheritance for identifying things as test contexts. It gives flexibility in how you organize your tests. And so these were the individual tests. Well, to run them, we would wrap them up in a module. So, and that module would be something called, for example, list testing, and it would accept, just like in other examples, it would accept the platform, probably, would accept a reference to the testing module, so that we can extract, like at the first line in the first slot, we could extract the test context class. And it also accepts the class that we want to test. So this module is parameterizable by the actual class that we want to test. So this is a very good feature in general, because our tests are written against a certain API. So we expect that list understands messages and remove and includes. But the actual class that is used for these tests, the class that we instantiate to test the behavior, it is something that we provide from the outside. So we can use the same tests for testing if we have implementations of different implementations of lists, say array list and linked list. We can use the same testing module to test both implementations. And so, and this is how we define what we're testing. So this is something that you point your testing tools at to run them. So we define a testing configuration. So this is where we say what exactly we're testing. So a testing configuration is something that, well, the important part there is it retrieves this one will test the class linked list. So it retrieves the linked list from the collections in the platform, and in the method that creates the modules that the framework will use to run these tests, we pass the linked list, the factory for linked list in those modules. So this way we create a testing module that tests the right thing. And if we want, well, as I said, if we have another implementation of the same API and we want to test it, well, we define a different configuration that, well, I can jump between these two slides and you can see what changes here. So we just replace references to array list, to linked list with array list, and well, we'll rename the slots. And now we're using the same testing module that we defined before for testing the list API with a different class. Or we can define a configuration that tests both at the same time. So here we create, and this is something we haven't done before, but here we create in the method at the bottom, we create two instances of the list testing module. So one of these instances is parameterized with array list as the class to test, and the other with linked list as the class to test. And so now, running this configuration, it will test both classes. And, well, as a final example, shared state. So, for example, let's say we are writing compiler tests. And creating a compiler to test is something that is expensive. And, well, that was the case with the JavaScript compiler. And so in this case, we want to reuse it, and this is what we would need resources for in the original system, in SUnit. So the way to do it in the Newspeak framework is, well, we write our tests as a subclass of text context in the testing module, and then we wrap them in another class, which is whose purpose is to hold onto that instance of the compiler that is expensive to create as a state that will be shared by all instances of parser tests that we create as we run the tests. And so the framework is written so that it recognizes, well, it correctly creates the chain of nested objects that are specified there. And then as tests are run, it instantiates test contexts for each of the tests that needs to run. But the compiler is shared by all of those objects, and so it is not recreated. And this is how you do resources. So there's nothing special for resources. You just create a class one level up, and you have your state that you can share. So, well, I understand that some of this may have been confusing because it was too much, but, well, these slides will be accessible, and also, I guess, the recording of this. And so, well, now this is something that you can revisit and refer to well, re-educate yourself in Newspeak. Okay, any follow-up questions?
Is there, what we've seen is that applications are created declaratively. Is there anything like saving the image and bringing back a
yes, there is an image. So what we looked at here, this window, well, if you noticed when I started it by, well, here I have a Newspeak image, which really is a squeak image, well, with our stuff in it. So yeah, at any point you can save the image. So even though we have this discipline for the way you define your applications, and we use that discipline so that you can package your applications and like deploy them elsewhere, but you still have the interactive environment, and you have the image with the state that you can take a snapshot of and then come back later. So these two things, they don't contradict each other.
Can you go to the packaging slides, please?
This one?
One more like
this one?
Yeah. The second line, Hopscotch equals platform Hopscotch. What happens if you have a spot called platform and you put the platform in there?
If I had a, what would I?
If I understand correctly, the line where it says, well, the second line, which is Hopscotch equals platform Hopscotch.
Mm-hmm.
So if I understand correctly, you're defining a slot there and you're getting this.
Right.
What would happen now? Can you technically actually define a slot called my platform and put the platform in there without sending any messages to it?
Yes, you can. These are just slots.
And will the packager then work? Because you actually put the whole platform there?
Well, if you just put platform in it, yes, it would work because you don't send any messages to platform. So it records the messages that you send to it. But yes, there's a certain amount of discipline that we expect here. So we expect nothing prevents you from putting other things in that in there, arbitrary computations. But if this is an application, you're not supposed to use it if you expect it to be packageable. That's it. Okay, thank you very much.